Hello everyone, welcome back to CoScience. I'm Dr. Bimala Samaratunga. Okay, today we will discuss um, A-level A-level mechanics paper, paper 4, 2025 May June. Okay, so here we are going to discuss paper 42, mechanics. So now I'm not going to explain the instructions. So I hope you everyone uh, familiar with these instruction and all. Okay, so let's let's get started. Okay, so the first question: the crater is being pushed in a in a straight line along a horizontal surface by a force of magnitude 25 Newton, inclined at 20 degrees above the horizontal. The crater moves a distance of 12 meter in 8 seconds. Okay, with a constant speed. Okay, so the first part, find the constant speed, and it's 1 point, so it should be a really simple and easy one. So we can okay, as they are saying that this is moving with a constant speed, right? So we can simply use v equal s over t. So we can write constant velocity v equal s over t. So from this one, the distance traveled is 12 meters and okay, divide by 8, right? Okay, so 12 over 8, which is 3 over 302. If we divide by 4, so then it's 1.5. So 1.5 meters per second. It's really easy. Okay, then find the work done by the 25 Newton force. Okay, so first, okay, let's make a sketch like how this happened. So we have this horizontal surface, and so we have this object, and as they say, the force applied with the 20 degrees with horizontal. Okay, and so the force is 25 Newton. And then it travels for 12 12 meters. Okay, so the work done, we can calculate work, let's say W. Okay, W equal the force. Okay, so here you have to remember we define this work done by the force multiplied with the distance or displacement in the same direction of the force. So this object is moving horizontally. In that case, okay, so we have the distance horizontally, and in that case, you have to have the force also the horizontal. Okay, it should be the horizontal one. So we have to take the horizontal component of this 25 Newton. So, uh, okay, we can write the formula F times the displacement, force line, the displacement, and the horizontal component, we can write 25 cos 20, right? And the displacement is 12. Okay. So with this one, you can calculate. So it will be 281.9. But you know that we have to keep our answers in three significant figures. So we can write 282 joules. Okay. Then find the power at which 25 Newton okay, force is working. So now you have to find the power. So we can write the power P equal the rate of the work done, or W over T. So we calculated already the work done, which is this one 281.9. So I would take that one because okay, if you take 282, it is a rounded up one for three significant figures. So it's better to use 281.9. So 281.9 divided by time was 8 seconds. So then it is 35. It will be 35.23. Okay, so we have to keep that in three significant figures. So we can write it as 35.2 watt. Cent. Okay, so that's all for the first question. And then, okay, now let's move to the question two. So as they are saying, mm, okay, two particles P and Q of mass 0.2 kilogram and 0.1 kilogram respectively are free to move in a straight line on a smooth horizontal plane. Okay, P is projected towards Q with a speed of 5, and okay, then at the same instant Q is projected away from P with a speed of 2. When P collides with Q, the particle coalesces. So then they stick together. Okay. So find the kinetic energy loss during the collision. Okay. So we can, okay, let's make a sketch. So, okay, before collision, we have the particle P moving with the speed of 5 meters per second. And then we have particle Q moving with a speed of 2 meters per second. So this is before collision. Then after collision, what will happen? So both uh, both the particles are stick together, and so we don't know the speed after collision. So let's say after collision, it is moving to the right, so you can assume it to the right with the velocity of. Okay, so then how we can find? Okay, so this is the target. They are asking find the kinetic energy lost during the collision. So what you can do? So here my target is we can calculate the initial kinetic energy, right? Because you know the velocities and also the masses. So before collision, you can find uh, the kinetic energy, and then we apply the collision theories. Okay, and then we can find out what is the velocity after collision. So we can compare. We can compare kinetic energies. So by taking the difference, if there is one, then that will be the kinetic energy loss during the collision. Okay, so so here what we are going to do, we can see, we apply the conservation of momentum, right? So considering the conservation of momentum, okay, so we can write momentum before collision should equals to momentum after collision. Okay, so before collision, the mass of P is 0.2, 0.1. Okay, so you can write. So here, uh, all the objects or particles are moving to the right direction. So I will consider the right direction is positive. So 0.2 times 5 plus 0.1 times 2. So this is the momentum before collision. Then after collision, they stick together, so you have to add the masses and the velocity is v. Okay, and so with this one you can find v equals, so 0.2 times 5 is 1, and then here you have 0.1 times 2, so 0.2, so total is 1.2, divide by 0.2, 0.2 plus 0.1, 0.3. Okay, so here we can just remove the decimal places because we have only one decimal places. So 12 divided by 3 is 4. Okay, so after collision, the velocity of the system or combined particle is 4. So now we can write loss in kinetic energy. Loss in kinetic energy, we can write kinetic energy before collision minus kinetic energy after collision, right? So kinetic energy we calculate half mv square. So before collision for particle P, half the mass was 0.2 and the velocity was 5 square, plus particle Q, the mass was 0.1 times 0.1, the speed was 2 square. Then minus after collision, so half mv square again. So the total mass is now 0.3, and we calculated the velocity after collision, which is 4. So here 4 square. Okay, so here 5 square is 25, and then here 0.2 we can divide by 2, so 0.1. 0.1 times 25 is 2.5, plus okay, here you have 2 square, which is 4, divided by 2 is 2, and multiply by 0.1. So then it's 0.2, and here minus. Okay, here you have 4 square, which is 16, divided by 2, 8. 8 times 0.3, which is 2.4. Okay, so then the total, okay, so here you can simplify, it will be 0.3 joules. So in these cases, here, try to try not to use the calculator for simple calculations because it may wasting of your time. Okay, so try to do by mind, practice, and so you can save maybe just a 5 second from a question. Okay, so if it is possible, try to do by mind all the calculation. Don't depend on your calculator. Okay, so now let's move to question number 3. Okay, so it seems related to the forces. A particle P of mass m is attached to one end of light inextensible string of length 2.6. You can see it. Okay, then it is attached to this horizontal ceiling and the string is taut. Okay, the particle is held by an equilibrium force. Okay, so that is important. So particle is in equilibrium. Okay, and okay, with a 35 Newton force, and that force is perpendicular to the string, and the mass is m, blah blah blah. And then okay, you have to find the value of m, the mass of the particle, and tension. Okay, so let's indicate tension. So it's a tension, I hope you remember. So if it is a tension, like let's say here we have a string, so tension always we indicate like this. to the inside. Okay. Or let's say if it is a compression, then we indicate the forces as the outside. Okay, because we compress something here, we compress. So then the force acting or generated inside the string is to the opposite direction. And here you have um, uh, a tension. That means we pull it out. So then always the force acting or generated inside the string is to the opposite. So that's why here we have that one. Okay. I will begin it. Okay. So then, right. So we can indicate the tension here. We are interested here. So tension is upward and okay. And then we have the weight uh, of this object. And then here, if I do this. Okay. So now we have a problem because uh, the angle of a string we don't know and they didn't give us, right? So you have to decide. So in this case, I will select the angle of the string with the horizontal as theta. Why I took that one? Because here, so now when I draw this dotted line, so it makes a right angle triangle. So 2.6 is the hypotenuse, and here, according to this angle, the opposite is 2.4, right? And so you can apply Pythagoras, right? By applying Pythagoras, you can find out this length, the adjacent. So hypotenuse is 2.6. So 2.6 square equals to, let's say the adjacent we don't know. So a square plus opposite is 2.4. So then a is this one, 2.6 square minus 2.4 square. Right? So if you calculate it, you will find the answer as 1. So here the length of the adjacent is 1 meter. Okay, so with the help of that one, you can write sine theta, cos theta, and tan theta. Okay, then here, okay, this angle is theta. Therefore, here this dotted line is also horizontal, and so this angle should be theta. And okay, and also we have to find out the angle for 35. Okay, so this is theta, right? This is theta. Therefore, this angle is 90 minus theta, right? But this total, this angle is 90. So this small piece is 90 minus theta. That means this one should be theta, right? Okay. So I will leave it like this. Okay. So now let's try to find the values. So always check properly the question. And okay, in this case, this is a 2D situation. So since this object is in equilibrium, then we know the condition. So the total forces, the sum of all the forces in x direction should be 0, and sum of all the forces in y direction should be 0, and also the moment. Okay, it should be 0 at any point. So in this case, we no need to consider that one. So we can just consider this. So if you consider horizontal forces, we can simply neglect uh, the contribution by the weight of this one. So I will start with that. So I can write, since the particle is in equilibrium, So I will consider the direction. So I will consider right direction. The sum of all the forces it takes direction is 0. So with this one, okay, we can write the component, horizontal component of 35. So this angle is theta. So then I can write 35 sine theta. 35 sine theta. Okay. And the other force is to the opposite side. So minus t cos theta equals to 0. And okay, with this one, I can bring t cos theta to the other side. So I can write t cos theta is negative. When it goes to other side, it's positive. And this side we have 35 sine theta. So I can divide both sides by cos theta. So sine theta divided cos theta is tan theta. So 35 tan theta. Then 35 tan theta we can write. So theta here. Tan means the opposite divide adjacent. So 2.4 divided by 1. 2.4 divided by 1. So it will be 84 newtons. Therefore, the tension T equals to 84 newtons. Okay, done. And then we can consider the vertical components. Okay, so since this is in equilibrium, so I will consider the upward forces are positive. So the total forces, sum of the total forces in y direction is 0. So what are the components here? We have a component from T, so T sine theta plus, and then here with 35, so we rotate to this anticlockwise, so theta is there, so then 35 cos theta, and minus we have mg equals to 0. Okay, so what we can do now, okay, we can bring mg to the other side. So because mg is minus, so we can bring to the other side, so then it's plus, and then we can divide both sides by g to subject m. Okay, so I can write m equals e sine theta plus 35 cos theta divided by g. So now we can substitute the value. So t is 84 times sine theta is 2.4 divided by 2.6. 2.4 divided by 2.6 plus 35 times cos theta is 1 over 2.6. 1 over 2.6 and divide by g is 10. So we can use the calculator for this one. Okay, so here we have main division, so I will use this one, and then 84 times, then again we have a division, so 2.4 divide by 2.6. Okay, and then plus we have 35 times, again we have a division, so 1 over 2.6, and total divide by 10. So we have 9.1 divided by 10. So by taking the decimals, so it is 9.1 kilograms in this case. So therefore the mass is 9.1. Okay, done. Right. So let's move to question number 4. Okay. So a car is traveling along a straight horizontal road, car passes through a point A on the road, traveling at a speed of 15, and then this okay, accelerates uniformly 0.4 for 30 seconds. The car then moved at a constant speed of 3t seconds, where okay, t is less than 30. The car decelerates uniformly at 0.2, and after a further okay, t seconds passes to a point B. Okay, so you have to draw mm, you have to draw the velocity time graph. Okay, so here, as you can see, so if it is not clear, what you can do is make a sketch. Let's say this is the point A, right? So as they are saying, at point A, when it is passing point A, the velocity is 15 meters per second. And then it moves with an acceleration of 0.4 for 30 seconds. T equals 30 seconds. And then after that, okay, another 3t time travels with a constant velocity. Okay, constant velocity, and then after 3t time, it starts to decelerate. So the deceleration is 0.2. Okay, we will put negative because it's a deceleration, and then pass the point B after t time. So we don't know the velocity at this point. So let's say v2. Okay, so this one. So you have to draw the graph for this. And okay, they gave you 2 points for the correct graph. Okay, so let's start. So here at time 0, okay, at time 0, it passes point A with a speed of 15. Okay, so then we will take something like this. Okay, so the initial here velocity is 15, and then 30 seconds it moves with a constant velocity. So constant velocity means a horizontal line like this. Okay, let's take like this. Okay, and so we don't know that velocity value. Let's take v1, and after that okay, it decelerate. So the gradient should be less than the previous one because the acceleration was 0.4. Deceleration is 0.2. So the gradient should be less. Okay, so then it passes this point B. Okay, we don't know that velocity also. Let's take v2. Okay, so now let's indicate the time. Here, the acceleration time is 30 seconds. And then here it moved. Okay, 3t time. And okay, let's take this deceleration time also. So 30 plus another 3t. So this is 3t because this length is 3t because it travels 3t time, and then under deceleration it moves another t time. So then the total time is 30 plus 4t. Okay, so this is the graph. This is what you have to indicate. And then the next part, they say that the distance from A to B is 2750. Find the value of t. Okay, so they gave you the total distance from A to B. So you know that in a velocity time graph, the area under graph gives you the distance traveled. Okay, so then in that case, we have to use that concept. But here in that case, we have a problem because we don't know. Okay, here as you can see, the okay, if you consider this accelerated motion, so you have a trapezium. So you should know the length of the parallel lines. So here this one is, we know it is 15, but here the bigger one, we don't know, it's V1, right? Okay, so what we can do? So here, if we consider the accelerated motion, we know that the gradient of the graph gives you the acceleration, right? So I will write here, considering the uniform acceleration, considering the uniform acceleration, I can write A equals the velocity difference. So this height, so V1 minus 15, and the time is 30. This one equals to 0.4 because the acceleration rate was 0.4. So with this one, you can find out V1. So what you have to do, cross multiply 30. So 0.4 multiplied by 30. And then here we have minus 50. Goes to other side. Okay. So then I can write V1 equals to 0.4 times 30 and here plus 15. So the value is 27 meters per second. Okay, so this value is 27 then. Now here also we have this trapezium at this decelerated motion. So in there we have to find out the area. So we should know this length. So we know the height of the trapezium, which is t, and one parallel line is v1, the length. So we found it 20 as 27. The other one is v2. So we have first find it. So I can consider the uniform deceleration. Okay, so considering the uniform deceleration, okay, so in there we can write A equals V1 minus V2 over T, which is equals to 0.2, right? The deceleration was 0.2. Okay, so V1 is 27 minus V2, and I can cross multiply T. So then it is 0.2 T. Okay, right. Then, okay, with this one we can subject V2. V2 equals 27 minus 0.2 T. Okay, so let's take that one as equation 1. Okay, done. Then, okay, we can go. Okay, so we have all the information, and so now we can consider the distance traveled. So we know that in this graph, the distance traveled or the gap, in this case, distance from A to B is given by the area under graph. So I can write uh, distance from A to B equals to area under graph. So the value was, okay, as they gave us, it was 2750. Okay, so now we have to find the area. Okay, so in this case, here the first trapezium with the accelerated motion, So the length of parallel line 15 and 27. The height of that one is 30. So we can write here 15 plus 27 divided by 2 times the height is 30 plus, then here this uniform velocity region. So in there the height is 27 and the width, let's say it is 3t. So 27 times 3t plus, and then this is small trapezium under deceleration motion. So here the one parallel line is 27 and this shorter one is 27 minus this one minus 0.2t, which is v2. So we have we have to write sorry, 27 plus v2 is 27 minus 0.2t divided by 2 multiplied by the height of the trapezium, which is t. Okay, right. Then okay, now we have to, so here as you can see, here uh, we have only t as a variable, right? So what we have to do, we have to just simplify this one and find the value for t. Okay, so let's start. So this is, I will keep this one as it is, and here we have okay, 15 plus 27 and times 30, so divide by 2, so that means we can just take here. Okay, so we can just take 15 plus, here we have 27 multiplied by 30 divided by 2 is 15, so we can take 630. So here we have 630 plus, here we have 27 times 3, 50, so 81t, and then okay, here what we can do, okay, here 27 plus 27 is 54, and here also 0.2t, so we can divide by 2. So again 54 divided by 2 is okay, here plus is 27 minus 0.1 t times t. Okay, so now here as you can see, when I multiply by t to expand the bracket, we have t square. So minus 0.1 t square. So I can bring it to the other side. So it is plus. So 0.1 t square. And then I have here 27 times t. So 27 times t. Okay, 27t and here plus 81. So which is 100, 108. So I will bring to the other side. So it's minus 180. And then here we have 2750, and I'm going to bring 630 to the other side. So it's minus. So it will become then that's 2120 equals to 0. Okay. So now it's a quadratic equation, so you have to solve it. So let's do something like this. We will apply the formula, right? Minus b plus or minus that one. So minus okay, minus, and b is 100 minus 108 plus or minus b square. So minus 108 square minus 4a is 0.1. Then C is this one, 2120. Divide by 2 times a 0.1. Okay, so now here when you come to this place, so it will take a small time to do that one. So I would say write it down, this one, and this is a secret. Okay, so you can use your calculator to find out the answer easily. Go to mode, and when you go to mode, then you can find the equation here. You can see as a EQN. So here it's number 5. So it will depend on the type of the calculator. And then when you press 5, okay, now here you can see the equations. So here in number 3, this is a quadratic equation. So you have this quadratic equation from number 3. So you can just press number 3. So then they're asking what are the ABC values. So A is 0.1, press equal. Then B is minus 108, press equal. C value is 2120. Okay, so then again press equal. So then here you will have, so T equals, sorry, 1600, 1060, or again press equal. So the second answer is 20, or T equals 20. So from this one, like, they know that, okay, you apply the formula, but we did a shortcut. So you no need to simplify all. So you can use the formula and write the answer. So then they will think, okay, you use the formula and found these answers. Okay, but now here we have two answers. But do you remember? Here they told us that t is less than 30, right? So we can say, since t is less than 30, the answer for t is 20 seconds. Okay, so done. Right. Now, okay, here we have another part. Mm, okay, the car continues its journey. Okay, its journey from B, and then, okay, decelerating uniformly at 0.5 until it's come to rest at a point C on the road. Find the total distance from A to C. Okay, so if we consider now B to C motion, so let's say this is point B. Okay, so at point B, now we know the velocity, which is v2, and then at point C, it will come to the rest, and the deceleration was 0.5. So first you can try to find, okay, so in this case, first you should know the velocity at point B. So I can write velocity at point B. Okay, so which is v2. We found it previously, it is 27 minus 0.2 t, right? So 27 minus 0.2, sorry, t is 20, sorry, 20, right? It is 20. So, okay, so it's 4. So then 23 meters per second. Okay, so then we can apply for B to C motion. Oh, B to C, B to C motion, we can apply, we We know the final velocity is 0, initially is v2, we found it. We know the acceleration, and so we can find the distance, right? So we can apply v square equals u square plus 2as. So final velocity 0, initial is 23 square, and we have a deceleration. So we can plus times minus 0.5 times s, let's say bc. Okay, so from this one I can write s b to c. The distance from b to c is 23 square divide by, okay, minus, and then 2 times 0.5 is 1. Okay, so which is 529 meters. Okay, therefore we can write distance from A to C. A to C, the previous A to B distance was 2750, plus here B to C is 529. So the total is 3279 meters. Okay, so that question is done. Now we can move to question number 5. So, so here we have one end of a light inextensible string is attached to a particle A of mass 3 kilogram. The other end of the string is attached to particle B. Okay, okay, right. Particle A is in contact with a rough plane. Okay, so then this surface is rough. Okay, this plane is rough. Inclined to 30. Okay, and the horizontal, the particle B is in contact with a smooth horizontal. So this plane is smooth. Okay, and okay, attached to particle C, blah blah. Okay, the both string are taut and pass over small pulley are fixed at the end of horizontal plane. The part of a string from A to pulley is parallel to the greatest line. So here, and then okay. The system is released from rest. In the subsequent motion, C moves vertically downwards with an acceleration of 2. Okay, neither A nor B reach pulley. Okay, so now when they release the system, C start to move downwards with an acceleration of 2. Okay, so we have the mass of this one, so we can write 5g, and this one start to move with an acceleration of 2 meters per second. So since all these particles are connected and the strings are taut, then all the particles has the same acceleration. Okay, so let's say so this one also moving, so with this acceleration to 2 meters per second and also the particle A is also moving with the same acceleration. Okay, so that's done. Then also we have to indicate the tension of each. But okay, here since this is in inclined, so I need to consider this one also, and this surface which the A is there, it's a rough surface, so I have to consider the I have to consider the contact force also. So let's say RA. Okay, which is, so this angle is 30, therefore this angle is also 30, and the tension. So we can consider this one T, let's say AB. So here also we have this tension between A and B, and also here we have another tension from B to C string, tension BC. So here upwards tension BC, and also since A moves upwards, so then there is a friction of A. Okay, so we and here the weight of particle B I did not consider, because the particle is moving horizontally. So then there's no effect from vertical force. The weight of particle B is vertical, so we no need to consider. Right, find the tension in each string. Okay, so we can consider here, if you consider particle C, you can see only two forces. So, sorry. So you from with this one, you can easily find the tension of BC. So for particle, so I can, so particle C, I can apply downwards F equal ma. So downwards we have 5g force minus TBC, and the mass of particle C is 5 multiplied by the acceleration is 2, right? Okay, so with this one I can bring TBC to the right side and 5 times to 10 to the other side. So I can write 5g, which is g is 10, so it's 50 minus 5 times 10. 5 times 2 is 10. So it is then 40 newtons. Okay, so the tension of BC is 40 newtons. And then, uh, okay, and then again, now you have to find out TAB. So you can consider particle A or B. But here, as you can see, for particle B, you have only two forces, TPC and TAB. So you can simply apply that one for particle B, because if you select A, you have to find the friction and so on, right? Because we have a lot of forces there. So let's consider particle B. So for particle B, let's apply F equal ma here. So we can say T BC minus TAB equals to the mass was 2, acceleration 4, mass is 4, acceleration is 2. So with this one we can write TAB, I will bring to right side, and to 4.4 times 28 to the other side. Okay, so then TBC was 40 minus 8, which is 32 newtons. Okay, so right, we found the tension of the strings. Part B, find the coefficient of friction between A and the inclined plane. Okay, so we know that uh, how the friction coefficient and the friction force related to each other. F equal mu r, right? So the friction force equals to friction coefficient times the perpendicular contact force, right? Okay, so we need first that one. So RA. So RA is what? So from this one here, RA is the component of the weight of weight of particle A. So 3g cos 30. So I can write RA is 3g cos 30. Okay, so 3g cos 30 we can find here. Okay, clean. Okay, remember here previously we used this formula, so uh, you have to remove it. Okay, sorry. So shift, we can clear all 2 times. Okay, so now 3g is 10, so I will write 30 times cos 30. So okay, it is 15 root 3. So don't take the decimal answers yet because this is not our final answer. Okay, so 15 root 3. And then we need to find the friction. We don't know the friction value. So we can apply F equal ma along the surface. Right? So I'm going to apply here for particle A. So parallel to the surface, I'm going to apply F equal ma. So we have the tension TAB minus the friction force minus we have another component from the weight, right? Here from the weight we have 3g sine 30 minus 3g sine 30 equals to the mass was 3 and the acceleration is 2. Okay, so from this one FA, if I bring FA to the other side and 3 times 2, 6 to the left. So TAB we found it as 32. Okay, minus, so 3g sine 30. Sine 30 is half, 3g is 30, so 30 times half means 15 minus 6. So it is 11 Newton. Okay, therefore we can write F equal mu r from this one, mu equals F over r, which is 11 over 15 root 3. So with that one, okay, we have, okay, always when I have a division, I use this key to have division. So 11 over 15 times root 3. So you will have this answer, and here with the decimal you can have this. So you can write okay, so we don't need to write because we have already this one, and so the value we had is, we have to keep for 3 significant figures, so we can write 0.423, right? Okay, so the value is 0.423. Okay, what else? When the system has been in motion for 1.5 seconds, the string attached to A breaks. Then find the total distance that A travels up the plane from the instant that the system is released from the rest to the instant that A comes to the instantaneous rest. Okay, right. So then, okay, now under this case, this particle A moves 1.5 seconds upwards. So with the same acceleration of 2, right? And then after 1.5 seconds, it breaks. So we can first consider like the total distance like the distance traveled by A in the first 1.5 second, because at that time the string uh, is okay, like, so it it's not broken. Okay, so I will write distance traveled by, okay, distance traveled within 1.5 seconds. So we can apply along the surface because A is moving to moving along that surface. So what are the main things you should know? We have to find the distance. So S, we know the initial velocity, which is 0, start from the rest, and we know the time and the acceleration. So you can use S equal ut plus half at square. So let's consider that one S1. Initial is 0, 1.5 time plus half, acceleration is 2, and 1.5 square. So when you take this one, you will receive the answer 2.25 meters. Right. Now, okay, now after 1.5 seconds, the string breaks. So before break, just before break the string, we should find the velocity, because then we don't have an acceleration provided by that string, right? So first we have to know the speed. Mm, after 1.5 seconds, so the speed of A after 1.5 seconds. Again, we apply along the surface. You know the acceleration, you know the time. So we can apply V equal U plus A T. So we need this final velocity. Let's say V1, and initial velocity is 0 plus 2 times the time is 1.5. So it's 3 meters per second. Okay, so now you know the velocity just before break this string. Okay, so now there's no string attached there. So uh, we don't have that acceleration, 2 meters per second. So now we have a new acceleration. So we have to find it first. Okay, so let's write the acceleration. Acceleration of A when the string is repeated. So we can apply along surface F equal ma, right? So I applied upwards, so downwards we have the friction, right? Also minus the component of the weight, which is 3g sine 30, right? So we have cg, so 3g sine 30. 30, and the mass of particle A is 3, and the acceleration we don't know. Okay, so with this one, FA previously it was 11, we found it, and 3G is 30, 3 times 10, sine 30 is half, so it is 15. So we can write A is here minus 11 minus 15 and divide by 3. Okay, so then it will be minus 26 over 3. Okay, so it's moved with the deceleration because of the friction. Okay, so that means the velocity or the speed of the particle decreases, right? And so the distance traveled after 1.5 seconds. So then we can write, therefore, the distance traveled after 1.5 seconds, or we can say after uh, the the string uh, is broken. So we know the initial and we know the final because it stops. They are asking the instantaneous stop. So v square equal u square plus 2as. So v square is 0. Initial was 3. We found it. Here we found it 3 meters per second. And then minus 2. I put minus because here our acceleration is minus 26. So here 26 over 3 times, let's say, S2. So with this one, you can find S2. So I will bring this, I will bring this part to left side because then it becomes positive. So I can write 3 square is 9 times here divide by 3. So I have to cross multiply 3 and then 2 times 26. So equals to here 27 over 52. So I don't take the decimal answers yet. Okay, because this is not our final answer. Therefore, now we can write for the total distance traveled equals to, so before string is broken, it is 2.25. So 2.25 plus after uh, after this string is broken, the distance is 27 over 52. So total will be 2.769, but for three significant figures we can write 2.77 meters. Okay, so yeah, that question is also done. Right. Now let's move to question 6. Right. So they say that the particle P moves in a straight line and passes through a point A at time 0. The velocity v meters per second of point P at time t second is given by this. Okay, and then find the maximum. Okay, so this equation is applicable for the time duration from 0 to 3. And then they're asking, okay, find the maximum velocity of P in the interval of this one. So the maximum. So you have a graph or let's say an equation. So how you can find the maximum? So in general, we have to use differentiation, right? So you can differentiate this graph. So then you will have dv over dt with respect to time. Right? And then for a maximum or minimum point, we can equate the dv over dt to 0. So with that one, we can find the maximum or a minimum point. So in this case, it will be a maximum. Okay. So our equation is v equal to t plus 1, 3 over 2 minus 2t square. So we have to differentiate it with respect to time. So dv over dt. So the first one, you have the bracket. So first we meet the biggest one, the power. So we multiply by the power t1 plus, and then 3 over 2 minus 1, right? So 3 over 2 minus 1 is half. And then you have to multiply by the differentiation of inside. So 2t plus 1. Differentiation of 2t is 2 plus 1 is 0. So multiply by 2 minus the differentiation of 2t square. So 2 times 2 is 4t. Okay, this one. And I can simplify a little bit. So here 2 cancel. So I can write 3 2t plus 1 to the power half minus 4t. So at the maximum, at the max we dv over dt equals to 0. So I can write 3 times here 2t plus 1 half minus 4t equals to 0. So I will write 3 times 2t plus 1 to the power half equals to 40, and here power half means the root. So to remove that, I can take the square of both sides. So 3 square is 9, and so the power half removes, and I have to take the square of the other side. So 4 square is 16 and t square. Right, so now it's going to be a quadratic equation. So we have the 16 t square, and here you have 9 times 2, 18t goes to other side, so it's minus. So minus 18t, and 9 times 1 is 9 goes to other side, so minus equal to 0. So again, here it's a quadratic equation, so you can apply the formula or you can factorize it and so on. So in this case, I'm gonna have factorizations. So it's a quadratic equation, so we should have two factors equal to 0. So 16 I can have 1 times 16 or 2 times 8 or 4 times 4. So in this case, also here the two numbers are okay. Here 9. So the multiplication of two constant value should be 9. So 9 we can have 1 times 9 or 3 times 3 times 3, right? So in that case, by considering that, we can't take 16 as like 1 times 16 and so on, because we will have a bigger values. So I will have 2t and 8t. And so 9 I can write 3 times 3. Okay, here 3. So we should have minus 18. So if I put here minus, so then minus 3 times 8 is minus 24. And if I put here plus, then 2t times 3 is 6. So minus 24t plus 60 is minus 18. Okay. So I can write, therefore, from the first bracket, t equals, by equating to 0, 3 goes to other side. So 3 divide 2. Or the other one is t equals 3 goes to other side, so minus 3 over 8. So which is wrong because time cannot be negative. Okay, therefore t equals 3 over 2, or I can write 1.5 seconds. So that means this object or this particle reach to its maximum velocity at the time of 1.5. So I can write therefore the max velocity at t equal 1.5 second. So I can find v max with this equation, with the equation we have here, the velocity equation. So 2 times, in bracket, 2 times the time is 1.5 plus 1, power is 3 over 2 minus 2t square to 1.5 square. Okay, so we can have the value. Let's clean it up. So we have a bracket. So 2 times 1.5 is 3. 3 plus 1, 4. To the power, we can have here 3 over 2 or 1.5. And then minus, we have 2 times 1.5 square. So it is 7 over 2, which is 3.5. So 7 over 2, or we can write 3.5 meters per second. So this is the maximum velocity. Okay. Then let's say, okay, now it is given that in the interval of 0 to 3, the velocity of p is always positive. Find the distance of p of p from at the instant when p is moving at the maximum velocity. So now we have to find out the distance from A to the point where it reached to that maximum velocity. So now we know that it reached to its maximum velocity at 1.5 second, right? So the distance, we have the velocity equation. So the distance s we can find by integrating the velocity with respect to time. Okay, so s is now, in this case we have to integrate it from 0 to 1.5 because we know the time taken to reach the maximum velocity is 1.5. So the equation was t2 plus 1. Here we have 3 over 2 minus 2t square dt. Okay, so first you have to integrate this first one. Okay, so I will write okay, so you have 2t plus 1. So when we integrate, um, we have to add 1. So 3 over 2 plus 1, which is 5 over 2. So 5 over 2. We have to divide it by 5 over 2. Also here we have to multiply by 2 because here the coefficient of t is 2. So we have to divide by 2. Okay, keep that in mind. Then minus the other one. So 2 is a constant, so we can keep it there. And then the integration of t square is t cube or t to the power 3 divided by 3. So from 0 to 1.5. Okay. So I'm going to simplify a little bit here. So we will have 2t plus 1 to the power 5 over 2 divide by 2 here cancel, divide by 5. Minus here you have 2 3 cube over 3. So from 0 to 1.5. Right. So now we substitute the upper limit first. So which is 2 times 1.5 plus 1 to the power 5 over 2 divided by here 5 minus 2 here 1.5 to the power 3 divided by 3, then minus the lower limit, which is 0. So when I put 0 here, I will have 1 to the power 5 over 2 divided by 5 minus here 0, because when I put t0, it's 0. Okay, so now here you have to simplify those values. So the first one, I will take here 2 point, okay, again here 2 times 1.5 is 3 plus 1 4, so 4 to the power 5 over 2 means 2.5. Okay, we have to divide it by 5, so it is 32 over 5, 32 over 5, and here we have okay, 2 times 1.5 to the power 3 divided by 3, so 9 over 4, so it is minus 9 over 4. Here 1 to the power 5 over 2 means 1, so minus 1 over 5. So the answer will be, okay, we can use this one, so which is 32 over 5 minus, normally I take this division, no, not the division mark, okay, because there may chance to have errors, so it's better to use in this way. So 79 over 20, and in decimal 3.95. Okay, so 79 over 20 or equals to 3.95 meters per 3 significant figures. Okay, so it's done. Right. Let's move to question number 7. I think this is the last question, probably. Yeah. Okay. So, and it's 6 points. Right. Let's see. A particle P of mass 3 kg is projected with a speed of 8 up a line of a greater slope of a rough plane inclined. Okay, so remember here they say that it's a rough plane, and okay, the angle is with the horizontal is 30. P is projected from point A on the plane and comes to instantaneous rest at point B on the plane. P then slide back down the plane. The coefficient of friction between P and the plane is this one. So they gave you the mu value. So mu is root 3 over 12. Using the energy method throughout, so you don't have any option. You have to use the energy method. Find the speed of P at the instant it returns to A. Okay, so let's make a sketch, so then it will be easy for us to understand. So we have this horizontal plane, okay, and then we have this inclined surface, okay, so the angle is 30. So let's say we are projecting from here, this is point A, and here this is point B, okay, right. So let's consider, so let's make something like this, right, and let's take the distance from this A to B is let's take DAB, because if we want to find the if we want to use this energy method, we should know the height, and this angle should be 30, right? Because these two are yeah, this horizontal line and those are parallel, and so it should be 30. Okay, and now this is a rough plane, and we projected it with a speed of 8. Okay, so we have the weight of that one, so it's 3 kilograms, so 3g. Okay, and then at this point the velocity is 0, and then it is coming back, and so they are asking that downward velocity. Okay, so what else here we have? So we have to indicate the contact force because we need the friction. So when it is moving upwards, we have the friction Fa downwards. Okay, so far we have this one. So they are asking the velocity. So A, the particle goes from A to B, this point B, and then it's coming back. So here it start with 8, and then they're asking this velocity. So here it stops and then again coming back. So this velocity is uh, what they are asking. Okay. So now we have to use the energy. So we can assume that this level has a potential energy equals to 0. Okay, because we don't know compared to the horizontal or this flow, we don't know the height, right? So let's take at this point potential energy is 0. So okay, let me do something. No, sorry, I have to move this one a little bit here. Okay, so I can write this height. I can write this height. The hypotenuse is DAB, so I can write this height as DAB sine 30. Okay, so then we can apply the energies. Okay, so now first we have to find out the energies. Okay, so we should have, because problem is now we don't know DAB. So in the first case we can try to find out DAB. So for that one we have to consider now energies. So kinetic energy at point A. So initial kinetic energy, let's say initial kinetic energy at point A. Let's write kinetic energy at A. So we apply half mv square, half mass is 3, velocity was 8. Okay, so then we will have here 64. So then it's 96 joules. Okay, what else? Then we reach to this point B. So we can write the potential energy, because at the level of A we consider potential energy 0. So at point B, so we have a potential energy. So I can write potential energy at point B. Potential energy at point B. I will write potential energy at B. So we can write mgh. Okay, mgh. So mass is 3, Uh, G is 10, and then height is DAB sine 30, right? This sine 30. Okay, here AB sine 30. So sine 30 is half, so it is 30 here. Mm, okay, here 3 times 10, 30 divided by 2, 15. So 15, I can write this is 15 DAB. 15 DAB. What else? Also, we have an issue because why this object stops at point B? Because of the friction. So this particle has to do some work against the friction. So we have to find out that one also. Work done against the friction. So work done against the friction. Let's say WAB. So when we go from A to B. Okay. So work done we calculate by force, right? Force multiply by, so here's the friction force, huh? Friction force multiplied by the distance traveled. So here now the friction we can write as mu Ra, there is friction force, mu R, and times the distance is DAB. So mu they gave us as root 3 over 12. R is the component from the weight, right? So 3G cos 30. Okay, because this angle is also 30 degrees. So this force is 3G cos 30. Okay, so R is 3G cos 30 times DAB we don't know. So we can simplify this one a bit. Okay, let's use the calculator. So you have here root 3 divided by 12 times 3G means 30 times cos 30. So 15 over 4. Let's use like this 15 over 4 DAB. Okay, so these are the energies. So now we can consider the energy conservation. So considering the energy conservation. So how we can write here? Initially we had only a kinetic energy, right? And then what happened? Some amount of kinetic energy. Okay, here when you reach to point B, you don't have a velocity, so you have only potential energy. So if there's no loss of energy, then the initial kinetic energy should be equals to this total potential energy. But since we have a kinetic, the friction, uh, some amount of kinetic energy used to do work against the friction. So the difference between the kinetic energy and potential energy is the energy used for work done. So I can write here kinetic energy at A, that is the total, like initial one, minus the potential energy at B equals to the work done. So kinetic energy was 96 minus potential energy was 15 DAB equals to the work done was 15 over 4 DAB. So from this one you can subject DAB So minus 15 goes to other side. So 15 over 4 plus 4 plus 15. So 15 times 4 is 30. 60, 60 plus 15, 75. So 75 over 4 DAB equals to 96. Therefore, we can find DAB is 96 times 4 divided by 75. Okay, so it will be 5.12. Let's say meters. Okay, now that's done. So now we know this distance. Okay, so now you can apply again B to A motion. So now here it reached to 0, and so now we have to consider B to A motion. Okay, so let's move to here. Considering B to A motion, B to A, B to A motion. Now we have to find out the energies again. So potential energy at point B. Let's say P equals to again kmgh, mass is 3 times d, and h is now the height, like dab, which is 0.12 times sine 30. So for this one you can find the calculator. So 3 times 10 to, okay, times 5.12 times sine 30 is half. Okay, it's right. Sine 30. Okay, 76.8. 76.8 joules. And then we have to write, okay, so there's no other option to find out the velocity at, again, point A. So let's consider kinetic energy at that point. So kinetic energy at that point we can write, but we consider the velocity at that point is we don't know that, we have to find it. So kinetic energy at A. So kinetic energy A is half mv square. So mass is 3, and okay, VA square. So we can write 1.5 VA square. And also work done against the friction. We have to know that one also. Against the friction. So now from B to A equals to Fs, which is mu RA times DAB. So mu was 3 over 12. And then RA is again the same, 3G cos 30 times now DAB, we know that 5.2. So you can find it again here, you can simplify. So root 3 over 12 times 3G is means 30, and then we have cos 30 times 5.12. So 9605 or 19.2. Let's write 19.2. 19.2 joules. Now again, consider applying the energy conservation. Energy conservation. Now what happened? Initially we had the potential energy at point B. So all that energy transferred into the kinetic energy at A plus the work done when it is moving from B to A. Okay, so the potential energy was 76.8. Here it is 76.8 equals to kinetic energy was 1.5 VA square plus this value, the work done was 19.2. Okay, so VA is the root of this one, 76.8 minus 19.2 divided by 1.5. Normally we have to write plus or minus. Okay, so here root and then here division, 76.8 minus 19.2 divided by 1.5. So the answer is 6.196. 6.196, but for three significant figures, okay, we can write plus or minus. For three significant figures, we can write 6.0. So therefore, the velocity at A is 6.20 meters per second. Okay, so with this one, we finished the paper. So thank you very much. And please don't forget to um, like, comment, and share. And those who are not subscribed yet, so subscribe it. And feel free to ask any question in the comment section and share with your friends. And good luck. See you again.